CSEC scholars, welcome back to another live CSEC class. Tonight we're doing, in our graph session, we're doing transformations. We're continuing with transformations. Last two sessions in transformations, we looked at reflections. So there are four basic types of transformations that we do at this level. So that would be reflection, rotation, enlargement, and translation. So we're going to be looking now at translation. And I would say the translation is the simplest of the transformations, because all we're really doing in a translation is we're moving a point, or we're moving an object, a shape, a polygon, whatever it is. We're moving it from one position on the coordinate plane to another position using a particular vector, which we call the translation vector. And that vector tells us how many places we're going to move on the x-axis and the y-axis. How many places to the left or right or up or down are we going to move that point to take it to the next point. The original point or polygon or any shape, the original shape, the original figure is called the object. After we translate it and we shift it, we move it to another part on the coordinate plane, it now becomes the image. If you are given the object and you are given the vector, the translation, it's just a matter of adding the x values in the object to the x value in the translation to get the image. Likewise, you add the y value to the y value in the translation to get the y value in the image. The reverse of that would be if you are given the image and you're given the translation and you want the object, then you would subtract the translation from the image to get back the object. Or if you are given the image and the object and you want to find out what is the translation, what was done to that object to get the image, you would subtract the object from the image to get the translation. So let's go over to our GeoGebra and see what we are saying here. Okay, so let's see what we're saying. And by the way, before I share my screen, let me welcome Imani.
Good night, miss.
Yes, miss. Welcome, John. Welcome, Imani. Asar, welcome.
Hi, sir.
Hi.
And we also have, I see a Lone Ranger in the chat, and that's Jamani. Hopefully others will join us in the chat a little later. All right, so now to share the screen so that I'm not here talking to myself, as I often do. So that's it here. Yes, no. Seeing the screen, yes, no.
Yes, miss, we're seeing it.
All right. So how would it say we're going to draw this now? So if we have this polygon. All right. So give me the coordinates
Okay, miss, for
of
A,
A,
miss, is it 1 to 4?
1, 4,
For B, it's 4 to 1.
4, 1,
And for C, it's 8 to 4.
8.
Miss, we're going to reflect it in the y-axis and the x-axis.
We're doing translation tonight.
In translation, how do you do that, miss?
All right, so let's say the vector for the translation is 2, -1.
Yeah, very good.
That means to get each of the points in the image, so these are the object points, the original points, we need to add 2 to the x values and take 1 from the y values.
Okay, miss, could I go?
Okay, so where would the image of A be now?
Okay, so miss, it be 3 to 3.
So 1 plus 2, that's 3 on the x, and then 4 minus 1, 3. So that would be the new points. That would be the A, image of A. And where would the image of B
Miss,
be
B
now?
will be 6 to 0.
So 4 plus 2 is 6. So it's 6, 0, which is right here
Yes,
on the x axis. So that's
this one
B
for C
prime. And the image of C would be,
is the image of C. Okay, miss, it made 10 to 3. 10 to 3.
so 10 on the x, 3 on the y. That's C prime.
Looks easy.
All right. So yeah, like I said, the translation I think is the easiest one.
Okay.
So that would be the new triangle.
Hmm? So how you get this?
Hmm?
Add
How did you
2,
get
2,
the B primes?
you minus 1 from 1, you get 0 1.
We added 4 and 2, that's 6, and 1 and -1 is 0. So that's here.
I'm saying you only use the the common B coordinates to work that.
Common B.
Yes, miss.
It's
So for
point B. It's point B, so we add the vector to point B to get B prime.
2 plus 4 is
the
6.
vector.
Yeah, this is the vector. 2 to
This
the
is
6.
the vector.
Oh, I was wondering why. Okay, and you add it to that vector, so you use the vector for the equation.
We add the
Okay,
points to the vector, the x values and the y values.
Miss, could I go
okay, I
again?
get it, miss.
Miss, could I go again?
You have to wait. Wait your turn.
Imani's turn.
This one.
Lovely.
What's that supposed to be?
You can't be hoarding all the turns.
Mm.
All right, Imani. So here's your polygon.
Okay.
Ah. Mm.
All right. So you're gonna tell me the coordinates and the vector that we're gonna use to translate it is 6, -5. That's the vector.
Okay.
Tell me the coordinates of A.
Okay, miss. So A is going to be -11 to +5.
-11, 5.
to +5. B is -11, +2. C is -8 to 0. D is -6 to 2. And E is -6 to 5.
All right, so you're going to add the translation to each of these points and tell us where the new points
Okay, miss.
would
So
be.
-11 plus 6 is -5.
Mhm.
And 5 minus 5 is 0. So -5 to 0.
So that's here.
Yes, yes.
So this is A prime, which is what? -5, 0.
5. Yes, miss. -11 plus 6 is also -5, and -5 plus 2 is -3. So -5 to -3 for B prime.
-5 to -2,
Negative 3, 3 miss.
3.
-8 plus 6 is -2, and 0 minus 5 is -5. So C prime would be -2 to 0. Sorry, to -5. -2 to -5.
That's C prime.
Yes, miss.
Hold on.
And
Hold on. So C prime is -2, -5.
yes, miss. And Z prime is 6 minus 6 is 0, and -5 plus 2 is -3. So 0 to -3 is D prime. And E prime, -6 plus 6 is also 0, and 5 minus 5 is 0. So that would be 0 to 0. So that's right there at the
Right
origin.
here.
Yes, miss. And connect the lines.
And that's E
E prime.
prime, 0, 0, the origin.
Yes, ma'am.
So for the translation, the only thing that changes, you know what I should do? The only thing that changes, why isn't it not working? For the translation is the position.
Almost.
Hold on, I did something wrong. It should be here, right?
Yes, yes, miss.
All right, so this is the whole thing. So the size doesn't change.
Just the
The
coordinate.
the size doesn't change. The orientation could change depending on the translation, but the size does not change. Um, the angles remain the same. So the shapes remain congruent. None of them is bigger than the other for the translation. When we did the reflection, last week, what changed about the object? When we
Miss, if
got
it's
the image, what had changed?
miss, if it's reflected in the x-axis, miss, the y value will stay the same, and the x-axis will change. And if it's
So in
reflected,
terms of looking at the object itself and looking at the image, what changed about it? Did the size change?
no, miss.
No, miss. The way
Did,
it was
did the
turned could
orientation
change.
change?
Yes, miss, the orientation.
Right, so the orientation changed. The size didn't change, but the orientation changed. It was the opposite orientation. If it had been oriented to the right, it now looked to the left. If it had been up, it was now pointing down. For the translation, size remained the same. Most times orientation will remain the same as well. So what really changes is that the position on the coordinate plane that changes. All right, so Asar, your turn.
Okay, miss.
All right, so for your polygon, let's say we have. So that's your polygon, Asar. Tell me the coordinates for A.
2, 5,
Okay, so A is 2, 5. And B,
2, 2,
2, 2. And C,
2, 2.
for C,
Sorry, 4, 2.
4, 2. For D,
2, 1. 4, sorry, 4, 1.
4, 1. For E,
For E, 8, 3.
8,
Miss
3.
the 4, 1. Actually, I think it's
4,
3.91.
2. This one, right?
Yeah, I
Is
think it's 3.91.
is what? No, man,
3.91.
it's on the, it's supposed to be on the dots. It's on the dot. All right,
Okay.
and C,
5, 6. C?
sorry, F.
5, 6.
Okay, so I see why you're saying it's 3.9, but my intention was for it to be here. So working with it for there. All right, so
Okay.
the translation is 8, -4.
So the first value for A would be equal to 10, 1.
All right, so 2 plus 8 is 10, and 5 minus 4 is 1. So that's 10,
Move up to
1.
1.
So that's here. So that's
For
8
B,
prime.
for B would be 10, -2.
Hold on. 10, 1. And B prime would be
10,
10,
-2.
-2. So 10, -2. C prime,
That would be 12, -2.
So 12, negative 2. Mm-hmm.
And d prime would be 12 negative d. So just put one dot underneath it.
12, negative 3.
Miss,
Hmm?
from we draw the first one, from we draw the first angle, do we need to plot it? Or can we just look at it and
What do you mean? When you draw the first angle,
because when you draw the first angle, you know where the
where A
yeah,
is?
if you know where it is, you know where C B D E F are.
Mm-hmm. What's
So
the question?
do you actually have to plot it?
Yeah, yeah, you have to plot the object and plot the image.
Image so E prime will be 16 negative 1 and F
16,
prime
negative 1. Mm-hmm.
F prime would be 13 to
13, 2.
13
So that's F prime, 13, 2.
and then
Right, so
connect the
let's
dots.
connect them. So from A prime, this was A prime to B prime to C prime. Come, why are you giving me so much trouble? See, it doesn't want to plot in the corner. That's why sometimes. And then E is here, and F is there. Back to A. So those are our objects and image. So you notice orientation the same, size the same. It's just that we've taken it and kind of just shifted it across the coordinate plane. So as I mentioned, sometimes you're given the, what did I do? Sometimes you're given the translation and the object. So the object and the image, they are written horizontally. So they might say point A is 3, negative 5. The translation, the vector is written vertically. So let's say the vector is 4, 7. So we add the object to the vector and you know you're going to get the image. So that's 3 plus 4 is 7 and negative 5 plus 7, 2. So then object plus translation gives image, which follows that if you have the image and the object and you want translation, you would subtract the object from the image to get the translation. If you have the image and the translation and you want the object, you subtract the translation from the image to get the object. Follow? So this part of it now is just basic algebra transposing, depending on which ones you're given, which one you want, you transpose, right? So let's do a couple of those.
Miss, how much you talking?
Huh?
Miss, how much you talking?
You want what?
Miss, how much are we talking about? How much are we?
Just a couple, like one each.
That's it?
Yeah. You want more?
Let's go then.
You
I'm
wanted
very,
more than one?
Miss, I'm very tired.
You're tired?
Yes.
All the better then, because we just give you one.
I'm just after.
Remember our policy. If it's simple, we don't make it complicated.
Yes, Miss.
Yeah. If it's simple, we just leave it at that. It's simple.
Yes, Miss.
So we're saying then, all right, John, so you go first. So let's say, John, point C was -20,
20.
15, and I'm translating it using the vector -5, -14. What would be the image, John?
It's the image. So, Miss, the image would be 25. Negative
So
25.
set out what you would add. Set it out what you would add.
Okay. Um, Miss, what's the C again? Miss, what would the C with the
That's a point.
up point? Yes, Miss. So the point, Miss, should be -20 to 15 plus -5 to 14.
I remember, how do we write the vector?
Forward, Miss, you put it in the brackets. 5, Miss,
Vertically, right?
eh,
The
eh,
translation vector is vertical. The
Miss,
points are horizontal.
I
So
would,
what would be C prime now?
okay, Miss, C prime would be -25 to 1.
So it would be the -20 minus 5, which is -25, and 15 minus 14 would be 1.
Okay.
Okay.
Yes, 1.
So, Asar, suppose I have point D prime, and D prime is 0, -3. The vector that I use to get to D prime is -8, 13. I want to know what was the original point D. Asar. I'm
First,
looking at the image of D, which is 0, 3, and the vector that was used to translate the object is -8, 13. What's the original object?
so we change the signs, so it'll be 0 plus 8, so 8, and
What are
13
we
minus,
really doing? So
yeah,
why are we changing the signs?
because we're reverting what we did to the number.
So we're really subtracting the translation from the image. All right, so that would mean we're taking away the translation vector from the image. You're saying the signs would change. So
Yes,
we would
please.
have 0, 3, and this will become a plus 8, but it will become a minus 13, right, as well. Am I correct?
Yes, miss.
Yes, miss.
So what would be the object?
8. 0 plus 8 is 8. And 3 minus 13 is negative 10. No, 8 over negative 10.
So it will be 8, negative 10. All right, so Imani, your turn.
Okay, miss.
So Imani, I'm looking at an object. I'm looking at the image of F, and I'm seeing that it is 5, negative 17. And I'm looking at the object F, which is negative 6, 7. What is the vector?
Okay, miss.
What is the vector that was used to translate point F to the image of F?
So we would add them. Or, hold on, wait, no.
You would add the image and the object.
Because if we're adding when we're supposed to
So
find the object,
remember,
subtracting to find the
object plus translation gives image.
Exactly, teacher.
yes, miss.
Image minus object gives
Yes, miss.
translation.
That's yes, miss. I just realized.
Yeah,
So
image minus translation give object. So we are here. We have the image, we have the object, we want translation. So what do we do?
miss, we subtract f from f prime.
So the image minus the object, and that gives,
So 5 minus -6 is 11, and -17 minus 7 is 20. Sorry, -24.
okay, so the translation would be
11
11,
negative
negative
24.
24. Would you believe that's all there is
No.
to translations?
Miss,
Hmm?
I wanted class to answer early tonight.
You want for there to be more?
Oh, yes. It's a
You want for there to be more?
yes.
So if you're given in terms of the coordinate plane, you're given a point, a dot, just one single point, or you can be given a shape, a figure, a polygon, or some irregular shape.
Yes, miss.
So what you'll be asked to do, I'm just recapping. What I'm doing is recapping what you've done. So you'll be given the object and you're given a translation vector and asked to translate the object to get the new figure, which is called the image. So you plot your point, or you plot your points and connect them to get your figure, and you're going to add the translation vector to each point and plot your coordinates for the image, and you'll get your image. In the case where they're not using any graphs, they're just giving you some points, or just giving you the vector. So remember, the object plus the translation gives the image. Therefore, image minus the object gives the translation. Image minus the translation gives the object. And in a translation, the size and orientation will not change, but the position on the coordinate plane will change. It's like you're lifting it up, you're not turning it anyway, just lifting it and putting it down. You're lifting it up and putting it back down somewhere else. That's what you're really doing for the translation. So that now covers reflection, translation. So which one you want to do next, rotation or enlargement?
Enlargement.
Enlargement.
Yes. My
Okay.
favorite one.
So we can do enlargement next week Monday.
Yes, miss. Oh, miss.
Do you have any questions?
Yes, miss. Miss, are we going to be doing this pepper and CSEC class on Wednesday, Thursday, and Friday?
The what?
Mr. Pepper and CSEC class on Wednesday, Thursday, and Friday.
I'm not getting the question. When are we going to do the what?
Miss, I was asking if we're going to do the pepper and CSEC on Wednesday, Thursday, and Friday.
You mean the extra classes or the live classes?
Miss, the live classes.
Yes, definitely.
Okay.
Definitely. Mhm. Definitely. And during the holidays too.
Oh, well, yeah, I got my holiday.
Hmm?
Miss, when is holiday again?
The next month, the next week,
Next week?
the next 2 weeks after you go on after Friday come in,
Yes, miss.
next 2 weeks.
Okay.
But you're going to be at Easter classes, aren't you?
Yes, miss.
And we still will have our live classes in the
Miss, are we
evenings.
going, Miss, are you doing face to face as well?
Yeah,
Miss, online too?
yeah. Which one you gonna do?
No, yes. I think I'm going to be doing face to face. So,
You prefer the face to face?
well, miss, I do prefer face to
You
face.
prefer the online? Really?
No, miss, I prefer face to face.
Oh,
I can actually see your classroom.
well, you definitely would benefit more face to face.
Yes.
Imani, which one you prefer?
Miss face to face.
Yeah, definitely would benefit more
Yes,
coming face
miss.
to face.
Miss
All
also
right.
lots of
Mhm.
people prefer. Miss also people learn better face to face, and you could actually
Definitely,
understand the
definitely.
students better face to
Yeah,
face.
that's it. I mean, that's just the normal, natural way to go,
Yeah.
right? Yeah.
Yes.
It's the online is very tedious,
Tedious. Yeah, exactly.
very tedious, especially when it comes. Well, for me, the most tedious part of the online is checking the work afterwards. It's very
Yes.
tedious.
Because you have to use it on your phone and whatever you use.
Yeah, because of the format, and sometimes the pics don't come in good. The handwriting is terrible to begin with. It's just really tedious to do. So I much prefer face to face, but we'll see how it goes because some students are far away,
But
Mandeville and Kingston and all over the place. So they definitely would still need the online for now at least.
But miss, I don't know. I'm going to ask you tomorrow.
Hmm?
Miss, I have a question, but I'm going to ask you tomorrow.
Okay. So tomorrow it's algebra.
Yes, miss.
Algebra, one of my favorite
So
topics.
it's my favorite topic. Algebra and graph are my favorite topics in math.
Miss, to be honest, my favorite topic in math was only graph.
Oh,
And then it turned to algebra and graph.
yeah, I love graph and algebra.
Took so much to see.
And my least favorite topic in math is statistics.
Miss, my own is
My
trigonometry.
statistics to me statistics is like very complicated and it makes it boring sometimes.
Yeah, I don't really
It's
like
very tedious.
statistics.
It's very
Mhm.
why though?
And I also don't trust it either.
Yes.
Oh,
I
I
don't trust the answers that people give when they collect it, when they're doing questionnaires and you're collecting data. So I tend to just have a mistrust of statistics in general.
Yes, miss.
So it's my least favorite topic in math.
I don't know what my favorite topic is. Hmm.
my least
The-
favorite is trigonometry.
I'm okay at trigonometry. It's not bad. I actually used to like it. When I had just started learning it, it was probably my favorite topic in math at the
Mhm.
time. But I don't know what my favorite topic in math is.
Sarah, how about you? What's your favorite topic in math?
Um, Probably factorizing.
Okay, so algebra.
Yeah,
And do you have a least favorite?
cause like least favorite
Huh?
probably linear programming
Oh, that
because
that still falls under algebra mixed with graph. Yeah.
yeah.
Combination of algebra, functions, and graphs. Linear programming, it can be very technical, but I like linear programming. Which part you find difficult? Getting the inequations or plotting?
Just the inequations, but after
So
I get that, I should be
yeah,
fine.
so that's a challenge is translating the worded part into the inequations. Yeah, a lot of persons find that challenging. So in this live class here in the graphs, we're going to be doing linear programming again. I know we've done it already in other aspects, but for
Yes,
this
miss.
particular class, after we have done with the transformations, and then I think we're going to do cumulative frequency and those graphs, and then we're going to do linear programming again. So Dinsmore is saying his favorite is circle theorem and then algebra. He doesn't like number theory. It's boring. I guess Dinsmore is saying number theory is too easy. That's why it's so boring to him. All right, guys. So I'll see you tomorrow. I really want you to enjoy the rest of your night.
You too,
You
miss.
too, miss.
Bye.
Thank
Bye.
you, and I'll see you tomorrow. Goodbye to those in the chat.
Bye, sir. Bye,
Okay, guys.
miss.
See you tomorrow.
Bye, guys.
Hello.
Bye,
Bye.
Sarah. Bye, John, Imani. Take
Bye,
care.
miss.
You too.
Yes, miss. You too.
Okay, guys. So here is our schedule of live classes. Hello, CSEC math students. I know you are busy preparing for your math tests and your CSEC exams coming up. I have a very important question to ask you. Do you like my new hat? Thank you. Now, another important question. Have you ever gotten a math problem wrong simply because of making one little mistake? I'm sure you have, as thousands of other students have. Now, in this series, we're going to be looking at the common mistakes that students make with all the topics in CSEC Math. We're going to look at the common errors, demystify everything. Make sure you watch every video in this series so that you can avoid making those mistakes. So stay tuned. Hello scholars, did you know that most times when students get problems wrong in mathematics is as a result of one single error or one mistake? Well, this is absolutely true, and we're going to be looking at the common errors that students make in the different topics in mathematics. If we know the errors beforehand, we can certainly avoid making them. Are you ready? Come on, take my hand.